So, in the lab that hopefully you're finishing up today, you're doing the case of the 5 droppers. Now, as I'm looking at the droppers here, I see I've got compounds. Every dropper contains a compound, and the 2 compounds are going to react. So obviously, this is a double replacement reaction. The metal in one compound is going to switch places with the metal in the other compound, and that's why it's a double replacement reaction. And so we're looking for signs of a chemical reaction. And so as you're doing this, you're going to take each dropper. And so the first dropper, and I'm going to put is lead 2 nitrate, excuse me, since that is a transition metal. And I'm going to put a little bit of lead nitrate in each of these wells. It's what we call a well plate, to be able to see chemical reactions. And now I'm going to put that back. Now I'm going to get the HNO3. Of course, that's nitric acid, but I want my HNO3 to go in each of these wells. And you can see how easily it could have gone in the wrong spot. So I'm going to put each of these solutions in that row or column going down. Now let's see, we've got barium nitrate. Once again, wants to go where it wants to go, but I'm going to direct it, and you can see I'm just putting a couple drops in each well plate. If you overfill the well plates, it will tell you that they will like literally overflow. All right, now here's potassium iodide, Ki. So I'm putting a little bit of Ki. I don't know if I got enough in there, so let me put some more. Putting a little bit of Ki in each well plate. Now, my last one, potassium carbonate, K2CO3. So going right down, I'm going to do that. All right. Now, lead 2 nitrate is one of my favorites. So let me go ahead and get some more lead 2 nitrate. Now, going across this way, I'm going to put in the lead 2 nitrate. I'm going to be looking for signs of any chemical reactions, production of a gas, color change, the formation of a solid precipitate. Oh, look, there we got something. Now let me go ahead and put that lead nitrate back. Right? And so I see when I reacted the lead 2 nitrate and potassium iodide, I can see that yellow forming. That's actually a solid precipitate. I'll show you that one this week. That's an easy one to show you in a test tube. Can't show you really in a well plate, but you can see it here in a well plate. The other thing I can do is I can bring up the black background. Oh, look at that. When lead 2 nitrate reacts with potassium chromate or carbonate, excuse me, I get a white precipitate forming, and I wouldn't have known that unless I brought up the black background. And so that's really what you're doing as you do this lab. Now, sometimes it might take a couple times. The other compound I like is potassium iodide. There we go. Now, we've still got that same yellow precipitate, so that's a good check for us. And so going straight across, I would add this. And I don't think I have any other precipitates forming, but the way for me to check that is to pull that up. The other thing, and I think, so let me get some, this is HNO3, hydrogen nitrate, also known as nitric acid. We'll study those later in the semester. Let me put some here because I think some of them often give some bubbles. And so I was looking for some bubbles here. And so you're going to want to do that same thing, looking for some bubbles. Oh, I shouldn't be putting nitric acid in all of those. And now you see I've messed up. So I would have to clean all my cells and start over again. So as you're finishing up today's lab, I hope this helps you to learn better how to do these double replacement reactions.